Hi everyone, myself Konda Krishnudu, Assistant Professor of Physics, Department of Science and Humanities, MLR Institute of Technology, Hyderabad. Today I am going to explain about lasers. So coming to the overview of today's presentation, today I am going to explain about introduction to lasers, the process of absorption and emission, comparison between the three processes, next principle of a laser, which is also called lasing action, and finally population inversion. Lasers. So first of all, we should know the acronym of the term laser. What is laser? LASER. Laser is an acronym of light amplification by stimulated emission of radiation. Light amplification by stimulated emission of radiation. So what is actually a laser? Laser is a device. Laser is a device which produces laser light. Laser is a device which produces laser light. So laser light is different from ordinary light. It has some special properties. These special properties are monochromaticity, directionality, coherence, and intensity. So these are the four special properties of a laser, which are also called characteristics of laser light. The process of absorption and emission. So now we are interested here about these two terms, absorption and emission. These two processes are exactly opposite to one another. Absorption is the process of particle transfer from lower energy level to higher energy level, whereas the emission is the process of particle transfer from higher energy level to lower energy level. First of all, I am going to explain about the process what is called absorption. So absorption is also called stimulated absorption. Absorption is also called stimulated absorption. I am going to tell you why it is called stimulated. So to study about this, first of all consider the two energy levels, E1 and E2. E1, E2 are the two energy levels. Here E1 is called ground state and E2 is called excited state. The lifetime of ground state is infinity, whereas the lifetime of excited state is only 10 power minus 8 seconds. Lifetime is nothing but the amount of time spent by an atom in an energy level. From this we can say that ground state is morely stable and whereas excited state is unstable. Now to study what is called absorption, first of all consider a particle in the ground state. The particle is in the ground state. A photon of energy h nu is going to fall on this particle which is already in the excited state. So by receiving this photon of energy, particle is moving from E1 to E2. The particle is moving from E1 to E2. This process of particle transfer from lower energy level to higher energy level by taking energy from the external source is called stimulated absorption. As long as energy does not fall on the particle which is in the ground state, the particle does not move from E1 to E2. It will move only when it receives energy from the external source. That is why the term stimulated is given here. There is no spontaneous absorption, right? So here I am saying that particle is moving from E1 to E2. Why? Because the particle received an energy from the external source which is equal to energy difference between the two energy levels. From this we can say that based on the amount of energy that a particle receives in the ground state, it will make a transition to the excited state. Now emission. As I told, emission is nothing but the process of particle transfer from higher level to lower energy level. Particularly, there are two types of emissions. One is spontaneous emission. Now, what is spontaneous emission? So from this diagram, you can understood that there are two energy levels, E1 and E2. E1 is ground state, E2 is excited state. The atom is already in the excited state. As I told that the lifetime of excited state is 10 power minus 8 seconds. After 10 power minus 8 seconds is over, the atom automatically makes a transition from higher level to lower level. This process of particle transfer from higher energy level to lower energy level is called spontaneous emission. This process of particle transfer from higher energy level to lower energy level without taking energy from the external source is called spontaneous emission. In this process, a photon releases or one photon releases. Now, another kind of emission is stimulated emission. What is stimulated emission? Now, consider two energy levels E1 and E2. The atom is already in the excited state. Now, we know the lifetime of excited state is 10 power minus 8 seconds. Sometimes what happens is, even before 10 power minus 8 seconds, if an energy from the external source falls on this atom, in that case, it will make a transition from higher energy level to lower energy level. In that case, two photons will release. This process where the particle is moving from higher energy level to lower energy level by taking energy from the external source is called stimulated emission. Now, comparison between the three processes. So, these are the pictures through which you can understand clearly the basic difference between the three processes. Absorption is the process of particle transfer from lower energy level to higher energy level, whereas the emission is of particle transfer from higher level to lower level. Absorption is of only one type, that is stimulated absorption, whereas emission is of two types, that is spontaneous emission as well as stimulated emission. Even in the emission also, there is a little bit of difference between spontaneous emission and stimulated emission. So, during the process of stimulated emission, only one photon releases, and whereas in the case of stimulated emission, two photons will release. Right? So, in the case of both spontaneous and stimulated emission, emission of light takes place, but during the process of spontaneous emission, only ordinary light will be released from the device, whereas during the process of stimulated emission, laser light will be produced. So, from this we can say that stimulated emission process is very important to get a laser beam from laser device. But whereas all these three processes will take place inside a laser device simultaneously. Now, lasing action. So far, we discussed about the process of stimulated emission, and we came to know that for each particle transfer from higher level to lower level, two photons will release. If that stimulated process repeats, that repeated stimulated process is called lasing action. Lasing action is also called principle of a laser. That repeated stimulated process we can understood from this diagram which is given here. Right? So, here one photon from the external source is going to stimulate an atom in the excited state. As a result of that, two photons will release. These two photons again stimulate two more atoms in the excited state. As a result of that, four photons will release. These four photons again stimulate four more atoms in the excited state. As a result of that, 8 photons will release. This multiplication process goes on, increases. This repeated stimulated emission process is called lasing action. This is the principle through which we can get a laser beam from a laser device. Next, population inversion. So, here how to understood the meaning of the term population. Population in this lesson we have to understood like the number of atoms in an energy level. The number of atoms in an energy level is called population. So, in general, if we consider two energy levels, E1 and E2, there will, if the population of E1 is N1, if the population of E2 is N2, in general N1 is greater than N2. Number of atoms in ground state is always more than the number of atoms in the excited state. If that is the case, there will be a more chance to get stimulated absorption, but to get laser beam from a laser device, definitely there should occur the process of stimulated emission. For that, more number of atoms should be there in the excited state. That is, making N2 greater than N1 is called population inversion. What is population inversion? Making more number of atoms in the higher energy level when compared with lower energy level is called population inversion. Simply by this term we can understood. The term itself implies just we have to invert the population of ground state and excited state. That is what is called population inversion. The same we discussed here. So definitely N2 should be greater than N1 so that stimulated emission takes place to get a laser beam from laser device. Now, so we know in different energy levels there will be different number of atoms. How these number of atoms will be allotted or distributed? The number of atoms in an energy level is explained or distributed according to one equation or one distribution law, that is Boltzmann distribution law. So this is the equation through which we can understand the population of each energy state. When we move from lower level to higher level, population decreases. Population decreases. That we can understood from this term e power minus h nu by kt. N2 is equal to N1 e power minus h nu by kt, where N1 is population of ground state and N2 is population of excited state. So from this equation we can say that when we move from lower level to higher level, population of energy level decreases. Now the same we can understood from this simple diagram. This is the case before population inversion. In general, N1 is greater than N2. There will be more number of atoms in the ground state when compared with excited state. Once when we give energy to the particles of ground state, so that particles will move from lower level to higher level. As a result of that, N2 will become greater than N1. Population inversion takes place. Metastable state. So far we discussed about only two energy states. One is ground state, another one is excited state. I told that ground state is more stable state whose lifetime is infinity, whereas the excited state is most unstable energy state whose lifetime is very less, of the order of 10 power minus 7 or 10 power minus 8 seconds. But there is a very important intermediate energy state. That intermediate energy state is called metastable state. Now the question is, what is metastable state? The excited state having longer lifetime is called metastable state. The excited state having longer lifetime is called metastable state. The lifetime of metastable state is high when compared with excited state, that is around 10 power minus 3 seconds. Then what is the use of this metastable state? What is the use of this metastable state? So to get a laser beam from laser device, population inversion should take place. As a result of population inversion, the process of stimulated emission takes place. Due to that, laser beam emission takes place from laser device. For that, the role of metastable state is very important. Because of its longer lifetime, what happens is, in general, what happens when we supply energy from lower level to higher level, particles will move from lower level to higher level. The particles which entered into excited state will stay only for very less amount of time, of the order of 10 power minus 8 seconds. After that, what happens is, automatically all these particles will fall into this metastable state whose lifetime is large, around 10 power minus 3 seconds. Due to its large lifetime, it will accommodate more number of particles in this state. At one moment, what happens is, population of metastable state increases. As a result of that, all particles will make a transition from metastable state to ground state, releasing laser light. So from this we can understood that the role of metastable state is very important in achieving population inversion. Now coming to the summary, just we discussed about the very basics of laser today. What is laser? Okay, now particle transfers between two energy levels. About the three particle transfers we discussed, the process of stimulated absorption, spontaneous emission and stimulated emission. Also we discussed the process of population inversion and particularly principle of laser called lasing action. So that's all for today, and tomorrow we are going to discuss about one more topic in this lesson, lasers. Thank you.